All right. So I've got 5:35 up here. I'm going to get started. So yeah, welcome to COMP2404 Introduction to Software Engineering. I'm the instructor, Daryl Hill, and yeah, I guess thanks for spending your summer here. Hopefully it's not too, hopefully it's a bit of a good time. I know school can be tedious, but so this is a sort of a 3-hour lecture, not real. I mean, we're going to go to about 7 or 6:55. We'll take a 10-minute break, and then we'll return and continue until 8:25. So yeah, this is yeah. Let's see here. So I'm going to start. We'll talk a little bit about the course. We'll go over the course outline. We'll go over the calendar, which is posted on Brightspace. We'll go over a little bit of the expectations and the grading scheme and things like that. And then we will, what was next up? Then we will jump into an introduction. So we'll talk about, what we're presenting in the course, what we expect you to learn from the course, things like that. Okay, so to start with, yeah, I'm Daryl Hill, the instructor. Probably my office hours will be today, 4 to 5 or something like that, or possibly on Wednesday, just before the tutorial. The TA coordinator is presently Sean Benjamin. That'll change about halfway through the course. I will update you when it happens. Of course, all of your information for this course can be found on Brightspace. And we will be using Brightspace in conjunction with Gradescope. I don't know if you've used Gradescope before, but if you haven't, it's pretty straightforward. You'll be uploading your tutorials there. Some of you have already done it, which is great. There's an auto grader there, so you'll get your tutorial marked back right away. And then you'll also upload your assignments there. And the TAs those won't be auto graded, those will be marked by a TA, but we'll get to that when we get to that. The tutorials for this class are on Wednesday. You've either signed up for the early or the late tutorial. I think everybody prefers the early, but that's full. So we're going to do something a little bit different this semester. There's not going to be any office hours outside of the tutorials. So traditionally, we try to get people to get into the tutorials by taking attendance or something like that. I don't want to force you to come there. I want you to come there because we're giving you something of value. So the tutorial sessions are going to be, you can go there and ask about the tutorials, of course, or you can ask about the assignments. You can ask general questions. You can meet with the TAs. You can go there to just work on your code. It's going to be sort of an open session with TAs there to help you answer questions and things like that. So I do want you to use the tutorial sessions. I would like you to find some value there, right? So we're doing our best to provide as many resources as we can. And certainly I'd like feedback on that. But I think that'll work good because this way we can be sure that you guys can get to see your TA for office hours, right? Because you signed up for these tutorials, so you should be able to, we're expecting that you can make that time. In the summer, it's often difficult to schedule TA hours and things like that. So everything takes place during the tutorial on Wednesday. Yeah. So, all right, so the lectures, this is an in-person class. However, I do record the lectures over Zoom and I will post them up on Brightspace. Even though I guess the pandemic is over apparently officially, so hooray, but still if you're sick, you shouldn't show up to class. And so we try to give you as much flexibility in terms of consuming the lectures as possible. And also, you can go back and rewatch. I don't know who would want to, but if you did happen to miss a part of something or want to brush up on something, you'll be able to rewatch the lectures. Tutorials are small weekly programming assignments in C++ to be submitted to Gradescope, right? So these are the auto-marked ones. These are just, and we'll talk a little bit more about them. as the course goes on. Assignments will be programmed using C++ and uploaded. We're gonna try out Gradescope for that. Right. So this is a bit of a trial run for Gradescope. The school might buy a subscription, but we're sort of the guinea pigs for this. The office hours are during your registered tutorial in the tutorial room. In addition to that, there are forums on Brightspace where you can post questions, and the TAs or myself or Sean will do our best to answer them. Or, the other students can also answer them. The midterm will be in person during your registered tutorial. That's the idea, at least. If you guys, we'll talk a little bit about the schedule. I don't know if you guys have an opinion on what you want. I think I have something that's maybe a good schedule, but I'm open to other ideas. The final exam will be in person, scheduled by the registrar. Okay, so this course is an introduction to object-oriented software development in C++. It used to be just a C++ course. They've changed it to Introduction to Software Engineering. When will the exam schedule be out? I don't know. I can ask, I can find out, but I don't know off the top of my head. So we're going to talk about C++ is sort of unique. It's a very complicated language. It's a systems level language that is also object-oriented. So it has low-level, fine-grained controls and high-level constructs. A very complicated language. So what we're going to do is we're going to take all that complexity and try and rein it in using good software engineering techniques and write some good code. So we're going to learn a lot about C++ from a technical perspective. Pardon me, sorry. Excuse me. So basic language features. We're going to basically start from the bottom up, all the way through object-oriented programming and templates and things like that. Inheritance. Basics of object-oriented design. So object design categories, UML class diagrams, different types of documentation, things like that. Object-oriented techniques like encapsulation, inheritance, polymorphism. All right, so some of this, a lot of this is a review from 1406, where you've probably seen these things using Java. We're going to look at them again, but I guess in more detail, perhaps. So templates, exception handling, the STL library, files and streams, and software engineering techniques. So basically, memory management. A big part of C++ is properly managing memory, memory leaks or seg faults. And well, there's 100 things that can go wrong in C++, and you're probably going to see them all. So we're going to figure out strategies for how to sort of try and avoid those things from going wrong. Program organization, a little bit of testing and debugging, not as much as I would like. I want to get more in here, but for now, it'll be sort of, well, you guys will figure out testing and debugging mostly on your own, but we will talk about it. And design patterns. So design patterns are sort of the bridge between this class and 3004. When you get to 3004, you're going to be designing your own system. Here we sort of hold your hand a little bit. Test cases. Sean. All right. So there's no textbook for this course. Of course, yeah, you should have taken 2401. There's no textbook. There's several good ones if you like. These days, though, Google is a very good place for C++ references, for tutorials, for things like that. You can find all those things on the net. Generally speaking, don't need to buy a textbook. The lecture slides and class examples are also, some of your main references. The laptop requirement. So everybody in here should have a laptop. That was brought up 2021. Not for assignment answers, right? Yes, no cheating. We'll talk a little bit more about that because, of course, the landscape of programming is changing quite rapidly at the moment. So yeah, we'll talk a little bit about that. But you should have a laptop. There are some details on the specs and well, on the requirement itself and the sort of minimum specs that you should have for this laptop. And one of the main reasons is this e-proctoring. So we're this is the summer session. We got a little more time. We're going to do a few experiments. One of them is that I want you to be able to write the midterm on your laptop in an actual programming environment. So you could use, let's say, VS Code, write your programs, debug them there. VS Code will help you, with the little squiggly lines to show you where you made a syntax error and things like that. The nice thing is that's an actual programming environment that I can test you in, and I can ask, I guess not, it tests you on more aspects of programming than just, say, writing out code. And also I can ask you better questions, I guess. So yeah, we are going to try that. Perhaps it may or may not work out. I don't know. It's a bit of a trial run. The final exam. So the plan is for the midterm to be on your laptop. That does mean using COMAS, right? So I don't know if you guys have heard of it. There have been, I guess, concerns brought up by students, and rightfully so. You should ask questions because this will be running on your laptop, and it will do things like redirect your DNS server, which is fine. I mean, it's temporary. It will take screenshots. All right. So to make sure that you're doing everything that you should, it will tell us if you've opened a file that you shouldn't have. It won't tell us the contents of the file, but it will say, there'll be a little red flag, and you'll be able to see all of the things that it's recording, right? So it's all very transparent. Again, if you have questions or concerns, I encourage you to bring them up, right? It's also helpful for us to know sort of what you guys are experiencing. Yeah. Yes, that's the idea. Yeah. So it will be so here, I don't think there's any power outlets, but the plan is to have it in the tutorial, which has power outlets, right? So you'll be able to plug in your laptop. It will, we'll talk in more detail as we get closer. We're still sort of working out the details ourselves, actually. So yeah, so that's the idea. You're going to program in an actual programming environment that you're familiar with. Yes, it is open source code. You can review the code yourself, but really it's not, I mean, you can see everything that it's keeping track of. So yeah, we will do a little test run of it in one of the tutorial sessions about 2 or 3 weeks before the midterm. And then you can run it and you can see what it does, and you can raise, and I encourage you to raise any questions you have. Okay, I don't know. This is sort of still, I do value your feedback, and we can always go back to written tests if you guys are really, really concerned, but I think it'll be okay. I think it's been designed with transparency in mind, and yeah, anyway, we'll talk more about that as we get there. So there is a double pass rule in this class. Now I'm kind of flexible on it. The problem is last semester I had, let's talk in general. Let's look at this first. So the assignment total is 45%. That includes the tutorials. There's 10 tutorials plus 1 bonus tutorial. And that extra percent carries over, right? So you can technically get 11% here and raise your assignment total. Well, you can't exceed 45, but if you lose some marks on your assignments, you can boost that using the tutorials. The assignments, there's 4 of them. The 3 highest will count for 10% each, and the lowest will count for 5%. That is to account for the fact that, of course, life happens. You had a bad week or whatever, and you didn't do as well on one assignment or another. But so I want that flexibility in there, but I don't want to drop any assignments because if you only do 3 of the assignments, you're missing some valuable lessons. So I do want you to attempt every one, but I also want some flexibility. I recognize that, sometimes you're not at your best for whatever reason. That happens. The midterm is 15%, right? That's the final exam is 40, and so the tests are 55% total. So there is a double pass rule. You have to pass both parts. And the reason is, well, I marked the finals, and last semester I marked the finals of some students who, and the finals are, you're writing code that basically you've already written on your assignments, right? So I take your assignments, I take a simplified version of it, and I ask you to write a bunch of the functions. And there are some students who had no idea how to code. And they had perfect on all the tutorials and all the assignments. And I want to avoid that happening again. I feel like I need to apologize to Voya now, who runs 3004, because these students graduated or passed my class, and now he will be subjected to them. And they really have no idea how to code it. It's crazy. So, so yeah, that's the reason for the double pass rule. Now I'm not, and the reason is, if you're trying, I can be flexible about certain things, but I do want to avoid that situation. If you bomb the final, that means you don't know how to code, and I can't really pass you. Okay. All right, so assignments and tutorials are all mandatory. Tutorials, I think I let you hand them in late. Yeah. If the midterm goes well, it'll also be on your laptop. If not, it'll be on paper. Yeah. All right, other questions? Okay. Oh, sorry. Yeah, you have to wave. I don't know. I don't have my glasses on. No, it's to weed out really the situation that I saw last semester, where this person got perfect on everything and failed the exam badly, and failed in a way that it's like there's no way that they wrote their own stuff. So that's what I'm trying to avoid. So I'm not going to be really if everything is consistent, then I'm happy to pass you, but generally speaking, I'm zeroing in on the people that cheat on the assignments and then don't know how to program. Right. Sorry, other questions? Okay. Late assignments are never accepted. So tutorials you can hand in late, they're auto marked, I don't care. I think there's a 10% penalty, which sometimes I waive, but try to get them in on time. Late assignments are never accepted because these are marked by people, and these people also have lives, and it creates a giant mess if we start letting people hand in late assignments. And I think, what I used to do is I used to make them due on Friday, and then the late due date would be Sunday. But you guys are sort of mature adults, right? So I just make them due on Sunday. So all I would do is I would move the due date forward, or earlier, and then give you a deduction if it was late, but the deadline would still be the same. So please get your assignments in on time. Even if they're not perfect, get them in and we'll get some marks. It's your responsibility to ensure that all these marks posted are correct within 2 weeks of the date the marks were released. All right, you can't come at the end of the semester and argue about assignment 1. So yeah, please make sure that these are correct in a timely manner. First, communicate with the teaching assistant, and then if you cannot resolve it, you can email me and I'll take a look at it. Collaboration policy, of course, there's no collaborating on tests. Collaboration on assignments and tutorials is acceptable. I would hesitate to use the word acceptable. I would say encouraged, right? You shouldn't be, well, it's fine to program by yourself, but you shouldn't feel obligated to. right? In the real world, people ask other people questions, get help and things like that. So I do want you to feel comfortable asking questions of your fellow students. But when you write your code, just write your own code. That's all. I don't want you to see you copying and pasting somebody else's code. We will be checking for that sort of thing. So yeah, important considerations. This is just sort of reiterates what we said above. Late assignments are not accepted. Technical problems don't exempt you. Manage your time well, I guess, would be the lesson here. If you're ill for the midterm, there's the Carleton self-declaration form. You don't need a doctor's note. Just sign that or fill it out and email it to me, please. And then I will make sure that the weight of the midterm is shifted to the final exam. But yeah, no provision is made for missed assignments, no extra credit assignments. All right, so the official discussion boards are on Brightspace. Please post your questions there. I used to run a Discord server, but then I would always forget to check it. So I'm just sort of doing away with that because, yeah, I don't know. I would turn it off and then I would just forget to turn it on for weeks. And then a bunch of questions would be there that I never answered. So email me. If it's particularly busy, I may not get back to you. I may miss your email for whatever reason. If I don't get back to you in 3 days, email me again. I usually try to get back to people rather quickly, but some things happen. There is no Discord server. You guys can make one. I just don't want to. I don't want to run it. That's all. Yeah. All right. All materials. Yeah, I'm not really. This is sort of. Oh yeah, tutorials. No, you have multiple attempts to submit. In fact, you can submit as many times as you like, as far as the tutorials go. And then once you get a perfect mark, you can leave it. If you submit after your perfect mark, and then your next mark is not perfect, you have to go back and select the perfect mark again. But it's all doable. And if you can't figure it out, just let me know. That part's auto marked, so it's pretty flexible. Yes, the TA is the instructor. Yeah, so nobody from the faculty is obligated to be on any Discord that you guys make. You guys would have to, and you can. I mean, you absolutely can. But yeah, the official discussion forums are on Brightspace. The computer labs. All right, so there's some links here. I don't know exactly the state of the computer labs. I know they're moving things around at this point. Oh, when will the first assignment be posted? Good question. Probably by Wednesday. The assignment itself is, I mean, I have a working prototype of what I want you guys to build. I just have to update the specs. So this week, expect assignment 1 to be released. And then, yeah, there is a schedule coming up. The undergraduate academic advisor. These people are great. If you're not sure what course to take, if you're not sure how to graduate on time, all of these things, these are wonderful people. They're there to help. COVID-19 policies. So these are the new policies. Stay home if unwell, but otherwise, seems like the pandemic's over and we don't need masks. You can wear masks. If you come to my office hours with a mask, I'm happy to put one on with you. I can match your comfort level. Yeah, I have no problem with that. Vaccines are still recommended, but no reporting of vaccination is required. And yeah, this is just sort of, they're updating the air filtration systems and hand sanitizers and things like that. Oh, sorry, yeah. Yeah.
Instead of like, is that still a thing or?
Yeah. It's, you guys are adults. I think even the self-declaration form is, I mean, maybe a step too far, but If you miss the midterm, I trust you have a good reason. So but officially fill out the self-declaration form and send it in. I mean, that's really only for the midterm where that would apply. Everything else is, again, these lectures are recorded. So if you're sick, stay home, watch them on Zoom. It's not, yeah. Other questions? All right. Academic integrity. Yeah, if you get caught, you get sent to the academic integrity dean, and then you plead your case, and then you get some penalty or other. Read up on it. Yeah, and I guess in general, I'm not going to go into all the details here, but there are tons of resources. I'll get to this question in a minute. There are tons of resources at Carleton for whatever, whatever your problem might be or whatever challenges you might be facing. So I encourage you to use them when you feel they're necessary. This is not just a place of learning, of course, there's lots of support as well. So yeah. Do we have TA hours? The TA hours are during the tutorial on Wednesday. All right, so again, because the summer, some of you might be working, and it's hard to schedule TA hours that accommodate everyone, but everybody signed up for the tutorial. So we're going to try and have a, sort of a concentrated session there where you can go in and ask questions. You can, talk about your marks while you're there. There will be a schedule of the TAs who are available, because some will be on the early session, some will be on the late session. Yeah, I don't know. We're experimenting with this stuff. So the lectures posted, I probably just after class, I will go back to my office and upload them and post them. And then it takes however long for, I post them on YouTube and I post the links on Brightspace, and however long it takes for YouTube to, go through them and process them. That's how long it'll take for them to be posted. So yeah. All right. Other questions? Yeah. Yeah. No. Yeah, sorry. I do want to have everybody present. COMP, the only reason I want to do it is because I want to give you guys a live programming environment. But it's not as secure when you're not being watched. That's just the reality. Yeah. So yeah, that is a good question though. So the answer is no, there's no distance tests. Okay, this is just for in-person. And just to give you a live coding environment, basically. All right. Yes, all contact with TAs will be in the tutorials. You can email them if you have a grading issue and post your questions on the Brightspace forums. It's just easier in the summertime, people working and, otherwise having a life. Yeah. All right. Other questions? All right. So let's look at the calendar. I almost always start by looking at the calendar, just to remind everybody what's coming due. So there is a tutorial that's due this week. You'll find it on Brightspace, and it's due at 11:59 on Wednesday. I don't know if that's my pen or what. Okay. And again, you can submit it up to a week late. I put that up. And again, it's auto marked, so I'm kind of flexible. Right now, the plan is that if it's late, I'll deduct 10%. Yeah. So, and things like how to submit it to Gradescope, and how to test it with your test script. Those will be covered in the tutorial. So, yeah. All right, so what we have, since this is a Monday class, there's a bunch of Monday holidays during the summer, and during those, some of those I figured probably everybody would want the week off. So that you would have a couple of weeks at least during the summer to do something. Yeah. So the first one is actually coming up in a couple weeks, Victoria Day. So there are no scheduled tutorials here. Now, you know, I'm open to feedback. If you don't like this schedule, please let me know and we can talk about it. The tutorials are due on the day of the tutorial at 11:59. The assignments are due on Sunday. Again, this is because I expect some of you are working and the weekend might be when you do most of your work on the assignments. No one will be there to answer questions on the weekend, or at least they're not obligated to. You know, anybody could, of course, if they want to, but so yeah, do make sure that you get to the tutorials to ask questions. But I decided to make the deadline for the assignments the weekend so that you have extra time to work on it. So there are 11 tutorials total, and one is a practice midterm where we will be using COMAS, and it'll be worth 1%. It'll just be a small programming assignment, but we'll work out the bugs and you guys can hopefully convince yourself that it's going to be a good experience. Yeah. So here we have that Monday off, but I put the midterm during the tutorial that week. Now we can change that so you have the week off, but what that means is that you don't have this study session. And if I move the midterm to the week before, then it's, you know, it comes just after assignment 2. So I'm open to changing that, but I thought that would give you the most opportunity to study and get ready and things like that. But if you guys really want the week off, I don't know. I guess this is sort of putting you on the spot a little bit, but is this, I mean, in terms of the midterm date, would you rather have it on the 5th, July 5th or June 28th? What about, so who prefers July 5th? Who prefers June 28th? A couple people. Yeah, all right. It seems like July 5th might have it. So yeah, I don't know. I think it's a good compromise. June 28th. Right. Well, we can, I mean, if you guys are free to change your mind, we still have time. Just let me know. I do have to set things up with exam services. So if we're going to change it, we have to change it probably within the next week or two. And I'm willing to do that, but think about it. So we have another holiday in August, a complete week off, and then the end of the semester, and then the final exam. Okay, so that's our schedule. Questions? All right. Yeah, we can set up a poll in Brightspace. Yeah, that's a good idea. Okay, so we'll set up a poll in Brightspace. You guys can weigh in on when you think the midterm should be, whether you want that extra third week off or write the exam. Okay. So I'm going to let's talk a little bit about, well, actually, I'll start the introduction and then we will sort of come up on all the other parts organically. So we're going to talk about the course in general, the presentation, sort of the recommended way that I expect you guys to do code, because basically we want everybody to be running C++ on the same environment. But that's a little tricky because, well, we have the virtual machine, but that doesn't really work so well on the Mac M1, or at least last time I checked, it didn't. Yeah. Yeah. You have the 2401 image? Yeah, it should be fine. If it's Ubuntu 22.04, and if you do, it'll be in the slides, but if you check the version of the G++ compiler, it should be 11.3. And if that's, I mean, we're running code on a lot of different systems. We're going to be running it on OpenStack in the virtual machine and on Gradescope, right? So I'm relying on the idea that Ubuntu 22.04 and the compiler version 11.3 is going to be consistent. And I haven't had any problems with it. So yeah, you can do that. You can use that. You can, find an old laptop and set up Linux on it if you want. Efficiency tests. No, there's no efficiency tests. 2402, it's a little bit different because you are doing data structures, and efficiency is very important for data structures. In C++, efficiency is important, but I can't imagine it making a huge difference in the programs that we'll be writing. The tutorials will be multi-purpose, right? So we're going to try and, again, we're trying to present or give you guys a lot of value, right? So there'll be, when assignments are coming due, there'll be, assignment workshops where the TAs will go over what's expected on the assignments and help people out. There'll be, of course, the tutorial workshops. They'll be there to help you out with that. And they'll be there to answer any general questions you have. Again, feel free to show up and just work on your assignments while you're there. And then if a question comes up, you can ask, right? So we want to try and give you as much value as possible in these tutorials. The TAs may have an assignment workshop and maybe a demo for the tutorial if needed. Yeah. So yeah, we're going to try and give you as much value in those tutorials as possible, along with, it being the primary way to communicate with your TA. Yeah, tutorials, think of the tutorials as a study hall. Exactly. Right. So yeah, form a study group, work on the assignments, talk about them, things like that. All right. Okay. So there are two main aspects to this course. There's the software engineering, which we're going to talk about. Again, this is a lot of it is stuff you've seen in 1406. We're going to, yeah. No Zoom session, just in person. Yeah. I don't know, what did we decide about that, Sean? I can't remember. If
what's that?
Anyway, if I say something that's not true, Sean will correct me.
What was that, Daryl?
Oh, somebody was asking about zooming into the tutorial session. So I know that's,
No.
yeah, not that exactly, but anyway, well, if there's a change.
Yeah, it's need to be there presently, in presence.
What's that?
You have to be there physically.
Okay, so yeah, you have to be there physically. So yes, perfect. Thank you, Sean. It'd be nice if at least the workshops could be recorded. Okay, well, we'll take that into consideration. All right, other questions? Okay, so software engineering is one of the aspects. Again, we're covering 1406 ground, but we're going to do it in more detail. We're going to do it from the perspective of C++, which itself is very detailed. So we're going to, make bigger and more complicated applications. And along the way, we're going to find that that's very hard, but then there are sort of common solutions that people have found that make it easier and more reliable. Okay, so not all TAs feel comfortable being recorded, so it'll be up to the TAs. I think that's fair. So we're going to talk about program design. We're going to be talking about patterns and or common programming techniques that are useful, problems that have been previously solved and how to solve them. But you should also think of this as a C++ course. There's a lot, we're covering a lot of the technical details of C++ along the way. So it's sort of I would think of it as a combination introduction to software engineering, but it's also I mean, C++ is a very valuable programming language in certain domains, right? It's presently irreplaceable in certain domains, although people are trying to replace it with things like Rust. I don't think Rust is quite there yet, or maybe the community is just not there yet, but so far C++ is the only solution for certain things. All right, so software engineering. So of course, how you write your software is very important, but working code is the most important thing. All right, that applies in the industry, and that applies in this class as well. I want you first and foremost to make your code work. If you have to take a shortcut to do it, I would prefer you do that than to send us something that's beautifully designed that doesn't work, right? I want it to be working first and foremost. You can always ship poorly written code that works, right? As long as it's correct. You can update it later, you can refactor it. I mean, all code gets updated, but you can't ship code that doesn't work. So please, working code is the most important thing. The tutorials are a good exercise in that because they only mark if it works. They don't look at how you did it. I don't look at how you did it. You just get the mark if it works. So in software engineering, you're continually updating, fixing bugs. All software that you make will be modified. So it's important that it's readable, extensible, maintainable, right? So readable, other people should be able to come along behind you and see what you've done and understand it. Extensible means that I should be able to add features, right, without too much trouble. And maintainable, well, all code has to adapt to other code that's adapting. So you have to be able to adapt with it. And once you stop updating, it's only a matter of time until it's obsolete, right? Using a Linux operating system, I've often, I look up some application to do something or other, and I come across something that's not been maintained for a couple of years. And it's, it's a gamble whether that's going to work or not. Once you stop maintaining it, it eventually just stops working. Yeah, so code also has to work with other code. Most code talks to other code, not people, right? So it's important that code is designed to work well with other code. So in addition to having working code, all these other needs have to be addressed in software engineering. All right, so as programs get bigger, all of these things that we said are important become more difficult. So along the way, certain patterns and best practices have come to the forefront that helped to make these things easier. So things like testing, unit testing, systems testing, integration testing, doing all of those things, can really help make sure that you don't put together something that is just impossible to fix. Documentation. So our documentation, we're going to be looking a lot at UML diagrams. I'm big on commenting personally. I find it really hard to get it marked consistently. And my personal philosophy is that you should try and write code that is expressive. So your code should actually tell a story, and you should have little comments along the way, of course, and you should have a big comment to sort of explain the purpose of your class. But a well-written function can almost do without comments, right? It should be readable. But I find people's, idea of readable is very subjective, and having TAs mark comments got to be very inconsistent. So the rule is, if the TA has a piece of code that they can't understand and you haven't commented, then you will lose marks for that. But otherwise, just write clearly, right? Just try and, try and think of somebody else writing your code or reading your code. Anyway, got a little off on a tangent a bit there. Modularity, right? So we want to write small pieces of code with clear purpose and well-defined interfaces. That means it should be clear how to use them, and it should be clear what they do. When you do that, makes it much easier to build larger systems out of these. Design patterns. So design patterns came about because, well, basically to accommodate changing code, right? So there are ways to sort of isolate changes to a certain part of your code. If you have what's called the spaghetti code, then when I make one change over here, I have to think, well, okay, if I make this change, then I have to change this over here and this over here and this over here. And if you're doing that, that's a really bad code smell, right? You want, if I want to change something, it should be isolated. And if it's not, you're probably not using the correct design pattern. But even with the correct design pattern or language feature, you still might not get a perfect fit, right? It's still maybe it's not a round peg in a square hole, but maybe it's, you know, a rectangular peg in a square hole. So you still might have to, you know, there's something when you write code, it's called technical debt. It means that design patterns are borrowed from architecture. All right, I'm not quite sure what you mean by that, but yeah. Yeah, so there's something when you're writing these things that's called technical debt. It means you didn't really use the best technique. So again, I would rather have you ship code with technical debt than have perfectly designed code that doesn't work. So just keep that in mind. That's you know, very common in the industry to have technical debt where it's not perfectly designed, but you go back and fix it later. Also, we're going to learn about C++. Why C++? Well, one, this is a continuation of 2401, where we were learning about C, so that's a systems level language. C++ is also a systems level language, but it comes with high level constructs. So it sort of has this best of both worlds thing. It's very fast, very powerful, very complex, very easy to make mistakes in. Seg faults are bad, but what's worse is when that code works by accident when it shouldn't. So yeah, those are fun to try and find. Yeah, so here's a little, I guess, analogy about programming languages. Python and Java are great languages, you know, right tool for the right job. But the sharp edges have been sort of taken away from you, right? So Java has a garbage collector, Python, it's interpreted. I actually would have to, yeah. I would have to explore in greater detail what Python precisely does with memory. But all that to say is that there's certain things that you don't have to worry about when you write in Python and Java. That doesn't make them lesser languages, but you know, again, the right tool for the right job. C is a very simple tool, and you can do a lot with it, but it's not very complicated, right? It's not, doesn't have these high level constructs. It's not a very expressive language. You're writing basically almost on the metal. And then C++ basically takes C and then it adds a bunch of tools to it. It still doesn't take away the sharpness, the danger of C, but it does try to give you more capabilities. Right, so Python, Java, etc. are expressive. You say what you want done and the language handles the how. Python especially, and I love Python. It's a great scripting language. I just say, do this. It's almost like ChatGPT, but I should probably address that at some point. But yeah, I mean, that's the other reason for the double pass rule. All right, a little segue on ChatGPT, and it seems like the industry is going that way. Certainly, like things like Copilot, they're very useful. But you still need the domain knowledge, right? When it gives you an answer, you don't know if that's right. The problem is at this level, maybe it is going to be right. And that's actually, I mean, that's really the reason why that the final exam and the midterm are worth a lot more now, is because at least I can monitor, you know, I can take away those tools while you do those, and I can see how much programming you've actually learned, right? So these are great tools, but they're not, I don't think they're good learning tools. That's the problem. They're good for producing stuff, They're good for producing low-level stuff that's well understood. They can't, at least as far as I know, if you're making a new cutting-edge application, ChatGPT will not be useful for that. Or at least it won't be useful. You will have to specify it right down to the detail, right? Because if it's something new, then it's something that hasn't been on the net, and then ChatGPT won't know how to solve it. So they're good tools, and I don't want to. They're not good learning tools. Yeah, security considerations. Well, not just security considerations, but anytime you're putting together pieces in a way that's new, if you're making a new type of, I mean, it's great if you want to make Pong, right? Or something that's been done hundreds or thousands of times before, then ChatGPT will do it flawlessly. But if you're making something new, then it won't. It'll make mistakes. Yeah. So I'm not integrating it into the course at this time. At some point, I probably will have to. I'll just say you should probably play with it, but don't rely on it as a learning tool. You should really write these assignments yourself, so that you know how to do it. All right, so that's sort of yeah. Don't shoot yourself in the foot by relying on ChatGPT or Copilot. They look like fun, but yeah, when it comes time for the midterm and the final, you won't be using those. Okay, so you'll be writing your own code. So I would advise you to get the practice. All right, questions? Yeah. Yeah, so yeah, the other thing is that the TAs will be using ChatGPT and generating code that will be checked against the MOS. Now, yeah, I mean, your scenario is sort of exactly how it should be used, right? But yeah, again, I'm sort of relying on the I would say that's okay, right? But I mean, you really have to use your discretion. Don't get carried away with it. That's all. Yeah. Other questions? Is that completely muddy? Yeah. Hopefully write some semi-quality code in C++ of a medium-sized application, and learning not only that, but learning sort of some of the theories behind the things that make that sort of thing easier and harder, right? So that's the idea. You should be better programmers at the end of this. Although, to be fair, I mean, really, I'm showing you the first step. And then after that, you're going to go off into industry and you're going to become better programmers than I have ever been. All right. So I'm here to teach you, to get you to the starting line, essentially, to give you the proper tools to run the race, but then you're going to go run the race. Right. So that's the idea. I want to equip you with the right tools, the right understanding at a very low level, and then you're going to build on that throughout your career, and then live in $1 million mansion and whatever it is you guys are going to be doing. All right, other questions? Okay. So yeah, ChatGPT, use with caution. Again, most of your marks, you will not have it. But yeah, so high-level language like Python, Java, they're expressive. You just say what you want done. Python's great. I love it. It's great for scripting. It's not great for writing huge applications, but it's great for writing tests, right? I gave you a Python script for your tutorial 1 that you could run. And every tutorial will come with its own Python script, so you can run it to get an idea of what the grade scope server is going to be doing. So you just say what you want it to have done, and it'll do it. You don't worry about how it does it. It figures it out. And you don't have to worry about memory. It handles all that. We have to worry about memory in C++. The downside is it's less efficient. Python is great because it has duck typing. So this is great for scripting. It's not good for huge applications, right? The reason why we have static typing, which we'll talk about, is because it helps the compiler find errors for you. But yeah, so you have less control over how things are done at a low level. You don't know when memory is being released, which makes them slow, right? Java, you can sort of control when memory is going to be allocated or deallocated, but accessing memory is slow. You don't want it to happen at the wrong time. If you're writing, let's say, a AAA game, in the middle of your boss battle, you should not be allocating or deallocating memory, right? That should happen after the boss battle on the loading screen or wherever. All right. So yeah, systems level language like C, it's a small step above assembly, one very small abstraction layer. So that means you're writing code that's very close to what's actually happening with your CPU. But you can basically do whatever you like with it. You can do clever tricks, hacks. You can really micromanage your code and make it as fast as possible. So this is good for operating systems, device drivers, things like that. But it has very few high-level constructs, right? It has a struct, basically. It just jams a bunch of primitives together in memory and says, that's the most complicated thing in C, really. So it's not very expressive. You really need to micromanage your code. If you write a find function in C, you have to. It's kind of a nightmare sometimes, but C++ sort of is the combination of those two things, right? It has all of the low-level control. You have the ability to micromanage how your program does something. You can do clever hacks. You can do a whole bunch of things, but it also has high-level constructs like objects and templates that allow us to basically implement design patterns that allow us as programmers to get away with less work that accomplishes more, essentially. So it's in some sense the best of both worlds, but it's quite complex. It's just about 2.5 times as complicated as Java, according to the specification. So the philosophy behind C++ is basically freedom. They say you should be able to do whatever you want. They are not going to take away any tool from you. They recommend certain things, but any rule that they give you, they will give you a way to break that rule as well. So they want to give you as much control as you want. The price is, of course, it's really complicated, and most of the complexity comes from poor memory management. So memory leaks, seg faults, things like that, which you're going to see a lot of course, but then hopefully figure out how to fix them. Okay, so why do we use C++? Well, it's good for things like AAA games, right? AAA games, as far as I know, are basically, well, I mean, things are getting faster, but the games that push your machine to the limit are written in C++. That's just it. You need both of those high-level abstractions so that you can, write the interaction of all these objects, but you also need that low-level efficiency. Real-time systems where you need fine control, C++. Right, so if you need to have it efficient, but also you want that expressiveness, then C++ is your choice. And as mentioned before, why is C++ and software engineering a good fit? Well, because all of this complexity can be managed if we have a good understanding of the language, right? So we need to understand the memory model that it uses and some of the pitfalls. And on top of that, we're going to use good software engineering practices. So this will manage all that dangerous complexity, hopefully. So this makes this kind of a good fit, right? So software engineering is about feeling the pressure of building more complicated software, and doesn't get much more complicated than C++. So yeah, one goal is to write bigger, more complex programs so that you guys feel the pressure of trying to manage all this complexity. And then that will sort of force you down these roads of best practices. That's the idea anyway. Yeah, this is also about setting the foundation for COMP 3004. In COMP 3004, you will be designing your own code, right? So at least typically, it depends on who teaches it, of course, but it's a lot more open-ended in terms of I'm going to be holding your hand and saying, I'm giving you a design basically, and I'm making you fill in, the blanks. So I'm going to hopefully impress on you a useful design, but also you will have to solve a lot of problems that are specific to C++. And all of this is to get you ready for COMP 3004, where you design your own code, implement it, and then you have to live with all those consequences. So yeah, you're not quite free range programmers in this class. Our specification is quite detailed. It helps consistency with the marking as well, but also we want to push you, make sure you're learning the correct lessons. All right, so learning outcomes, a foundational knowledge of C++. We're going to stick to a very low level because I want you to understand that low level. And then when you use the more easier libraries and memory management techniques like smart pointers, you still understand what's happening, right? So that's the goal. So we're keeping it kind of primitive in here. We're not going to use smart pointers. We're going to manage our own memory. As far as I know, you will very rarely see raw pointers in industry. They will almost always use smart pointers or reference counting or things like that. It's just safer, but you should still understand what's happening. Those can still be abused. We're going to compile it ourselves using makefiles that we write, right? And you're going to see basically the C++ compiler is, I say it's primitive, it's dumb, but it's that way on purpose, right? Because it doesn't want to make any decisions for you. It's letting you make all the clever decisions. The rule of thumb behind the compiler is that it will do an optimization if there is no situation where that optimization works against you, right? So it has to be an optimization in every possible scenario, and then it'll do it. And there are certain things that fall into that category. But for the most part, the compiler is dumb. It goes in a very straightforward manner, and you have to be clever in how you compile things. That's what it's expecting. So you're going to learn how to think like a compiler to identify mistakes that are in your code and why the compiler is complaining, essentially. All right. Oof. All right. I feel like I'm talking a lot here. Okay, so we're going to object-oriented programming techniques, the learning outcomes. We're going to learn how to test, right? You're going to learn how to debug. You're going to learn about code organization, memory management, inheritance, polymorphism, and a little bit of refactoring. Memory management is going to be very important, as are inheritance and polymorphism. We're also going to be using UML diagrams to visualize our programs. And then we're going to look at a few simple design patterns and architecture styles. And design pattern or architecture style is a bit of a semantic argument, or maybe not, but basically it depends on scale. Architecture style is sort of how your entire code base is planned out, and design patterns are dealing with smaller parts of your application. Don't fall into the over-designing trap. That's sort of what I did initially. Once I learned all the design patterns, I was like, cool, I'm going to use them everywhere. And then you write a very simple piece of code that uses model view controller or something completely unnecessary, and you write a bunch of code, and then you realize, oh, all of this is completely useless. So as your code grows, you can sort of organically introduce these design patterns through refactoring. But yeah, design patterns are useful when used at the proper scale. All right, blah, blah, blah. Okay, so the tools that we will use, and then that should hopefully take us to the break. And then after the break, we'll see a little bit of coding, and I'll get into sort of the setup. I'm going to be using OpenStack. I'm going to be using VS Code to SSH into OpenStack. And that is sort of that, along with the VM, are the recommended ways to do your coding. And on the midterm, that's how you will be doing your coding, right? So you are expected to know how to SSH into OpenStack from VS Code. It's very simple. I'll show you. But yeah, so our tools, one of the tools is the Linux operating system, specifically Ubuntu. It's based on the Unix operating system, which was developed in Bell Labs. I'm not sure exactly which year. I would have to look that up. So Mac OS is Unix compliant. It just means it's, there's a set of commands and expectations, I suppose. And then after Unix was developed, Linus Torvalds developed Linux as a hobby to be roughly Unix compliant. And that's sort of taken off like wildfire. So Linux is modular, can be easily extended. It's open source and free, so you can modify any part of it. And so a lot of people have their own versions of Linux. Designed to be simple rather than user-friendly, although there's lots of, Ubuntu is pretty user-friendly. But, expect to be editing some configuration files. C++ started in 1979 at Bell Labs. Yeah, we'll get there. Yeah, so very developer science friendly. Initially written in assembly. This is, I think, Unix, not Linux. And then C was developed in Linux and for Linux, and then Unix. And then Unix was rewritten completely in C, and then Linux was also written in C. Right? And there's a couple of cool quotes here. Unix is simple. It just takes a genius to understand its simplicity. Right? It doesn't hold your hand, essentially. But I like this one. Unix was not designed to stop its users from doing stupid things, as that would also stop them from doing clever things. And that also applies to C and C++, right? There's a lot of, they expect you to be competent when you're using these things. Wikipedia. Is that ChatGPT? All right. So in the Unix family of operating systems, there's Unix, there's Linux, Ubuntu, which is the one we're using, Arch, which is, if you like pain, I guess, Mac OS, BSD, Solaris, which is used by Oracle, the company that maintains Java. Android uses the Linux kernel, so it appears in a lot of places. There are tons of Linux servers. Now, depending on if you Google that, you'll get a bunch of different websites that say slightly different things, but they basically all agree that most of the largest servers are Linux or Unix based. Yeah, Linux in top position. So this is one link. There's other links that say slightly different things, but the consensus is generally the same. We're going to be using shells to program. So a shell is just an interface into the operating system. It's a command line. If you've used the Windows command line, you're familiar with it. Yep. Oh. Yes, thank you. So yeah, it allows you to run commands on your operating system, look through the file system, compile and execute programs. So there's different shells available in Linux or Unix. I don't really know the difference. I don't think there's very much of a difference. Bash is the default one. That's what I'll generally use. If you have a shell preference, then you know more about shells than I do. But yeah, there's very little difference. Some commands that we're going to be using, ls to list the current files in the directory, cd change directory, the chmod. So that Python script I gave you, if you put it on your virtual machine, it might not run. You can use this command to make it executable, right? Because it doesn't have the permission to execute it. So you have to give it that permission. Yeah, we'll talk more about these. Cat, grep, if you understand these shell commands, you could do magic on the command line. I can't, I don't, every time I use grep, grep is great, but I have to look up the syntax every single time. Yeah, the people who know this stuff, you can do magic. You can pipe in input from one command into another and all kinds of things. Text editors will primarily be using Visual Studio Code. I usually start with a more primitive one, but yeah, copy and move. Yeah, we'll get there. But this time I'm going to, yeah. So CP is copy, MV is move. So for moving files or copying files. Yeah, so we're going to be primarily using Visual Studio Code, and the reason I'm primarily sticking to Visual Studio Code is, well, one, because it's pretty great. As far as anything Microsoft has made, this might be one of the top things. Yeah, I like it. And it also plays very nice with OpenStack, right? So once you set up the SSH capabilities, you can basically write code as if it's on your computer, but it's actually on, a server here at school. The only good thing, yeah. Well, they make games too. Steam is pretty good, I guess. So yeah, we're going to use these to write programs and make files and then run them. All right, so the compiler we're using is the GNU C++ compiler. The command is G++. You guys have probably used GCC in 2401. It's the same compiler. G++ just, you can compile C++ programs with GCC, but you have to tell it that it's a C++ program if you're not using the proper extension, right? So it's just safer to use G++. G++ assumes everything that you've written is C++. So yeah, we're going to run it from the shell, from the command line. So we're going to compile things from the command line, and then basically, yeah, this is something I talked about earlier. You want to be using some form of Ubuntu, 2204, right? And the G++ version should be 11.3.0. And if you do that, then your code should run on all of the platforms that we're using, right? So that's OpenStack, that's the virtual machine, and that's Gradescope. These all use this version of Ubuntu with this version of G++. All right, so if you set up, you can set up actually your Windows environment to run G++, but it's not going to compile properly. So you can do that and you can write code, but please test it on an Ubuntu instance before submitting, just to make sure that everything works. All right, yeah, so as mentioned, code must be compiled in the same environment it executes in. So Windows has multiple C++ compilers, including GCC, but it won't run on Linux if you compile on Windows. They're different libraries, they're just different operating systems. The other thing to watch out for, Windows file systems are not case sensitive, right? But Linux are. So I see a lot of, if you write in the virtual machine, you can write in what's called a shared folder. That means the folder lives on your Windows partition, but I'm going to access it through the virtual machine and run, basically compile and run things. The problem is that file system, because it lives on Windows, is not case sensitive, right? So it might run there, and then when it comes time for us to test it, it won't run on ours because in your make file, you used a small lowercase letter, and in your file, you use an uppercase letter. So do be careful of that. All right, so Yeah, we're at programming example P1, but before we start that, let's take a 10-minute break. I talked an awful lot. So yeah, meet back here at roughly 7 o'clock and we'll go into our first programming example. All righty. Okay, so I'm going to get started again here. Yeah, so we're going to jump into our first sort of programming example. First, I'm going to talk a little bit about using OpenStack with VS Code and SSH. Again, this is going to be probably how you are writing your midterm. Again, there's a lot of wheels in motion. There's a lot of people working on this and technical details that are maybe not quite finalized yet. So there might be other options. For instance, if you're actually running Linux, not in a virtual machine, but on your actual machine, then I don't know. We'll see. We'll see if COMAS can handle that. I'm not sure. But that would be ideal, actually, if everybody had a Linux box, but I don't think that's going to be the case. So I'm going to, let me see here. So OpenStack from Carleton. So there are, if you go to the Carleton OpenStack website, so to set up an OpenStack instance, there are, I mean, there's a lot of technical details, but there's a very good set of videos that walks you through every step. And if you do each step in those videos, then you will have an OpenStack instance. All right, so I'm not going to go through that. Again, this is something that we would cover in the tutorials. But the videos are very good and they're very short. They're about 2 minutes each and they walk you through each step. So I have an OpenStack I'm going to sign into. All right, so here is the dashboard. And yeah, I'm going to go to instances. So I've already set up an instance of Ubuntu. That's called the 22.04 Light Apps Desktop. And you can see here I have 2 IP addresses. Again, this stuff is covered in the video, but one of them is a public IP. This is not the 134 is publicly facing on Carleton's network. Right, so if you're at Carleton, you can connect to it directly. If you're at home, you need the VPN, the Carleton VPN, right, to verify your identity and prove that you're supposed to have access to this. So I'm going to connect to this. This is running on a server here at Carleton. I'm going to connect to it using VS Code, and that's where I'm going to run my code, at least as long as if it works. Okay, so this is Visual Studio Code. It's free. It's available on Windows, Mac, Linux. So there's no barriers here for anyone. And what you'll want to do is there's these extensions, and you'll want to install the SSH remote extension. Okay, this is all automatic. I've already installed it. If you click on this, it'll do everything for you. Very easy to use. And then at this point, what I'm going to do is, if I hit F1, it brings up these commands. It gives me the most recently used ones, which I've used, the remote SSH extension. But if not, you can just start typing it. It'll autocomplete it. So I want to connect my current window to this OpenStack instance. I've saved the IP address here. So I'm going to click on that. It's going to try and sign in with student. If you've not used SSH from the command line, I'm going to do that in a second. But basically, this is doing it for us. So enter the password for student at this IP address, which is the OpenStack instance. I'll put in my password. And I'm connected. So if I look at my file explorer, Here I have, this is files on the OpenStack instance. I want to open this code. It's going to ask me for my password again. And then, yeah, I have a test folder. It's empty, but I'm running basically VS Code connected to an OpenStack instance. This can be done from any machine, an M1 Mac, Windows, Linux if you want, although if you're running a Linux machine, you don't need this, at least not yet. So yeah, I know I didn't really go into a lot of technical details. I'm showing you generally what you have to do. You'd have to set up the OpenStack instance first, and then install Visual Studio Code and the SSH extension, and then know a little bit about SSHing in. But yeah, any questions? Yeah. No, it has to be in the operating system. So there's installing it in the VM is a bit of a problem because you could have a couple VMs running. Yeah, well, we've talked about this and we've decided that the best way to do it is through OpenStack, because when you're running a VM, either we would have to run 2 instances of COMAS, and then even then, I'm not sure if it's secure. I don't know. I have to talk to people who are smarter than me actually to know the answers. But yeah, that's not going to be a viable solution. Yep. If you have a Linux machine, you don't have to use this for coding. You'll still have to do it for the midterm. Sorry. Yeah. Question? Yeah, I mean, you Google SSH VS Code. It's very the Visual Studio Code documentation is quite good. So if you just go there, I'm sure you'll find details on that. Other questions? Okay, so now that I'm here, I can do terminal. So I can actually run a terminal. Now this terminal is running on, again, it's running on the OpenStack instance, and I can, list, and I see the test folder there. So there's a link in the chat there. Yeah, if you happen to be connected to Zoom, you can see it. If not, it's, yeah, basically if you Google Visual Studio Code remote SSH, it'll take you there. All right, so I can run the terminal from here. I personally don't like to do that. I'm going to use PowerShell. I'm going to SSH in again, but I do need this IP address now. All right, so I just like running a separate terminal. It gives me more room to see my code and then switch to this window and then run it. So I'm just going to SSH student at okay. So now I have my very own window. So now I'm SSH'd in there twice. It just gives me a little bit more real estate to use when compiling and things like that. Okay. So now that I'm set up, make that a little bit bigger. So I can start writing code. The nice thing about this is, let's say I wanted to, well, first thing I want to do is remove this test directory. Wait. Oh, sorry, CD code. Okay, so that test directory is gone. And what I want to do is I want to upload some files from here into my OpenStack instance. So I want to run this first example, this introduction code, and I'm just going to drag it and drop it. And it's going to copy it onto the OpenStack instance for me, which is really nice. Right, so very simple. You can use SCP as well, which is basically you copy files using SSH. Again, you'll have to Google that and or attend the tutorial where all of these things can be explained and or help you figure them out. If I write code here that I want to save on mine, on my home machine, unfortunately, I haven't figured out how to, I'm still kind of new to this as well. So I haven't really figured out how to do that other than using SCP, or else I can say, take this piece of code, file, save as, and show local, and I can save it on my local machine that way, right? So those are, it's not quite as convenient as dragging and dropping a folder. And I'm throwing a lot of details at you, but I just want you to get comfortable with being able to code this way. So yeah, if questions occur to you, let me know. What's that? Yes. There is, again, I haven't, I'm setting up this. I haven't explored that, but yes, I'm pretty sure that's possible. Right? Yeah. So yeah, there's I've actually heard of other instructors who have done that, who've set up. So when you go onto your instance, you download it from Git or whatever, and then work on it, and then commit it, and yeah. So you can do all that. I'm not going to, at this point, I'm not going to do that, but yeah. Other questions? Okay, so let's. Where am I? So if I list, I can see that. I will CD into it. And then I have a make folder. And what I want to do from here is simply add main.cc. This will be the first program that we make in C++. No, the SSH command, you can do that directly from the terminal. You do not need the, I mean, you could SSH into OpenStack and use Vim or Emacs if you like. If you're good at that stuff, I'm not. I can get in and out and do a few simple edits, but I'm nowhere near. If you ever took a class with Christine, Christine is a wizard at Vim, but I'm not. Yeah, good point. So if you're using Git, make sure your repository is not public, right? So it shouldn't be able to, if students search for it, they shouldn't find, basically your version of the assignment. So yeah, that's a good point. Okay, so we're going to start with Hello World, of course, the same as every other first program that we make in every other language. So I need input and output capabilities. I want to write Hello World to the console. So I want to include input output stream. All right, so this is a library that gives me some useful objects that I can use for reading and writing to the console. And we're going to be doing something else here using namespace standard. In general, this is not recommended in software engineering. We're going to make our lives easier by using it because we're writing basically small, simple programs. It allows us to get away with it, but namespaces are important to avoid naming collisions. The thing is, our programs are so small, we're not going to have to worry about that. So we're going to scope in this namespace, and then I want a main function. All right, so I have my return type. of my function, the name of the function, the parameter list, which is empty, open brace, close brace, and then I'm just going to say cout. So cout is the object that directs your input to the standard output. And I want to use my stream insertion operator. We're going to cover this in a lot of detail going forward, and then I will give it a string to write out to the console. And then I'm going to cascade. I'm just going to call this stream insertion operator again, and I'm going to call end line. Okay, so I get a lot of questions typically at this point. Can you do this? Yes, that'll work. That's a new line, the same as C. The big difference between that new line and this end line is the end line will flush your buffer, mostly. Sometimes it's results may vary, but the idea is that the end line not only puts a new line in there, but it flushes the buffer. So what does that mean? Well, if I say cout and I don't flush the buffer, then it holds it there for a while. Maybe you write a few more things out, and then at some point it decides it has enough things in the buffer, and then it prints it to the console. Okay, but this might happen at some point well after this line, which means that if there's an error that occurs, this line does not get printed, and then it's harder to figure out where exactly my code crashed, because it crashed somewhere after this line, but this is just got hung up in the buffer and never got printed, right? So we're going to use end line because it makes finding mistakes and bugs easier, right? So if I put end line, it flushes the buffer for me. Yeah, may cause some lag. All right. Okay, so that's our program. Technically, I should return an int, return 0, which means everything went well. And then I'm going to compile it and run it. So C++ is a compiled language. So we'll talk a little bit about what that means in a second. So I'm going to say G++, actually it's G++, main.cc. Okay, so that worked. That means there's no errors. When I list, we see I have my make folder, which has some other files in there that we'll get to later. I have my main.cc, which I made. And then I have this a.out. This is the executable that was created by my compile command. All right, so if I want to run this, I'm going to use /a.out. And we'll talk a little bit about why we have to do it this way, but this will run this binary, this code binary for us, and print out hello world. Okay, so what happens if I try to do a.out directly? So a binary is meant to be run and it's meant to be called. So if I just do this, it says command not found. So what's happening is that these commands are stored in various places on your operating system as defined by your path environment variable. So when I run a command, it's looking everywhere except for the current directory, basically, right? It's looking into all these different places that hold these executables for us so that you can run commands from the command line. But it's not checking the current directory unless I tell it explicitly to. And how I tell it explicitly to is I use the // This says, don't follow the path variable and look in all these different places. Just look in this current directory for this executable a.out. Okay. The other thing is a.out is sort of a weird name. I don't really like that name. I'm going to remove it. And I'm going to recompile it using another name. Okay, so one thing to watch out for, this RM is very, very unforgiving. You remove something, it's gone. That's it. There's no, you can set it up so that there's a recycle bin and that this actually goes to the recycle bin, but by default, it just deletes it. If you accidentally delete everything in your directory, it's all gone. So be very careful with this RM. I've done it before. It was not fun. Luckily, I had a backup. It was not quite in a great state, but yeah. Okay, so what I want to do is I want to say, well, I don't want a dot out. A dot out is a weird, silly name. I don't really, not very useful. Yeah, okay. I'll let Sean answer that question. You don't have to use OpenStack, but it is one way, and I'm just demonstrating it here for you. So the dash O, small case O, means I want to call my executable by this output file. So I'm specifying that I want this called main, and then after that, the file I want compiled, main.cc. And now when I list, I have an executable called main instead of a.out. I can run it again using the // and I get hello world. Okay, so that's our very first C++ program. Again, it's a compiled language. We're going to talk exactly about what all that means. Any questions so far? All right. Let's make sure. I think this is. Oh, yes. That's a good point. Yeah, if you do this, if you write G++-O, and then you put the file you want compiled, followed by, if you reverse the order of those two, it's going to overwrite your main.cc. And yeah. So yeah, don't do that. And also make sure you either have make sure you back it up somewhere, right? There's a lot that can go wrong here. Okay, let's look at, let's say we wanted to add another function to this. So we just have one function here, the main function. This is sort of the stepping off point for every C++ program. Let's say we wanted to write another function that we could call. I'm going to write a function called foo. And this function is going to say hello again. Okay. Okay, so now I have a function and I'm going to call it from my main function, right? So this is, I mean, you should be familiar with this from C and basically every other programming language. I can compile again, run my main. It says hello world and then hello again. Let's say from foo, which is great. So I made another function. I called it. That's pretty simple as far as programming goes. Maybe I want to organize my code a little bit better. I want my main function at the top, and I want my foo function underneath. It just looks better, right? So that when somebody's reading it, they start here, and then they can, they see I call foo, and then they can jump down here and look at foo and see what that is. So let's compile that, and I get an error. The compiler is not happy with me. Foo was not declared in this scope, right? So as mentioned before, the compiler is very primitive. It doesn't do anything. It lets you do all the clever stuff. So what it does is when I compile this file, it starts reading here, says include IOStream, great. Using namespace, awesome. Main function, great. Hello world, I know how to do that because I've imported this library and I'm in the standard namespace. Foo, I've never seen foo before. I don't know what you're doing here. I'm just going to abandon this. I don't understand. Yeah. Yeah, we'll get to that. That's coming up in the next couple of lectures. It's essentially, it's like a Java package kind of, but it's more flexible than that. So it's to avoid basically naming collisions, right? So I can have, there's different namespaces so that, right, there's only so many names for functions. And so if I write something like, well, let's say I didn't put this in. So now you can see that the compiler is saying, well, I don't understand anything you're doing here. but I can scope that into the standard namespace. So the proper way to call this object is standard : cout. And that's how you should do it. But we're cheating a little bit. We're saying, well, anything in the standard namespace, I don't have to scope in. I can if I want, but you don't have to. Basically, our program is so small and simple that there's not going to be any naming collisions. So, yeah. All right. So yeah, the compiler gets here, says, I've never seen this before in my life. I don't know what you're talking about. This is ridiculous. I'm just going to crash. So, and that's on purpose. The compiler is primitive. So what we have to do is we have to tell the compiler, I don't want to put foo above main, but I do have to tell the compiler that, hey, there is this function named foo. You don't have the details yet, but trust me, you're going to get them. All right. So what I'm going to do is I'm going to forward reference this function. I'm just going to give the function signature. So the return type, the name, any arguments, the parameter list, not the names of them, but the types. Here, there's no type. So the compiler sees this and says, okay, there's a function called foo. I have enough information here to know how to use it. It can verify the syntax when I call foo. It can verify that I did it correctly. I passed in the proper number of arguments. The return type is the correct, all of that stuff. So it gets here and says, okay, cool. This is a function. I can verify you use it correctly. I don't have the code yet, but I'm going to find it somewhere later. And then when it gets down here, it fills in this blank. It says, okay, foo is right there. Pity the foo. Right. All right, so we try compile again. Compiler's happy. I run my code. Hello again, or hello world, and hello again from foo. Okay, so again, just to emphasize, the compiler is very primitive. Just starts reading, doesn't do anything clever. You have to do all the clever stuff. All right. Questions? All right. Okay, so we'll come back to this example. So what we're doing as programmers is something akin to this. We type up some C++ source code, we compile it, it outputs program executable machine code, right? So this is code that basically can be fed into your processor and run at a very low, very fast level. So what happens is, well, as programs get bigger, we want to compile them in separate pieces, right? So we don't want to recompile an entire million lines of code every single time we make a change. We want to isolate those changes, compile into pieces, and then link them together afterwards. All right. So the pieces that we pre-compile and then link are called object code. So object code is the same as the executable. It has machine language instructions, but what it doesn't have is there's some little flag that says, don't execute this, right? Maybe there can be a main function there, but if I compile it into object code, it's not executable at this point. I can link it, but at the moment I can't execute it. So I'm going to link these different objects together. I'm going to tell the compiler in advance that, hey, I'm calling this function. I want to tell you about it. I'm not going to give you the code yet. I'm going to link the code a little bit later. All right. So let's take a look at our example again. So I want to have this foo function, but maybe I want to call it from a different file. Yes, so machine language files are specific for each operating system and their architecture, right? Which is why when we compile to Windows, it doesn't run on Linux or Mac. I think you can get I don't have a Mac, so I don't know, but I read that you can get G++ working on a Mac. You can get it working on Windows, as I said. But. All right, so what I want to do here is I want to make a separate file for foo. foo.cc. So I want to have this foo code, but I want to put it in its own separate file. Right? Because I want to compile this separately. If I compile it all together and it's a lot of functions, then it's going to take a long time. I want to compile them separately. So I'm going to put this in its own file. Of course, the compiler starts complaining right away, since this is in its own file. It doesn't understand what I mean by cout. Right? I didn't import the input-output stream library. I didn't say using namespace standard. But you know what? I'm fine with that. Okay, so I'm going to take away this forward declaration. Now there's a couple ways I can do this. The first way I'm going to show you is the way you shouldn't do it, although it will work. And then we'll show you the correct way. So it says here, foo. I don't know what you mean, but what I'm going to do is say, yeah, here I'm going to include foo.cc. All right, and we see the little squiggle goes away there, and even these might go away. Maybe not. All right. Okay, so let's try and compile and run this then. So again, I'm going to compile main. It doesn't like that. Foo not declared in the scope. It should be there. Oh yeah, sorry. No, that should work. Yeah. All right. Sorry. Let me think about this for a second. Okay. Well, we'll come back to that then. Well, that's always fun. Make yeah, no. Undefined reference to foo. All right. Why aren't you seeing foo.cc? Yeah. I mean, I can. All right. Let's try. Did I put it in the wrong directory? No, it should be here. Okay. Yeah. Yeah. I don't know. It's always fun when things go wrong. All right. So I'm not sure what's happening here. So maybe OpenStack is doing something a little bit differently. Yeah, I can do that, but because I included this after these, I mean, this should just really, yeah. What's that? Sorry. Yeah, I can perhaps. Well, all right. I'm just gonna. All right, we'll skip this. I suspect if I'll go to the actual example, then I'm gonna maybe come back to this using Windows subsystem for Linux and see if I get the same error. Sort of weird. Because I should be able to include this, and it should basically read this in. right? So you can see that it recognizes this now because Visual Studio Code is basically keeping track of all the headers and the dependencies. And so it's sort of recognized at this point that this foo is being included in my main.cc, and it's being included specifically after I made these calls. But let's, so it's recognizing that, but yeah, that's not going to fix it either. All right. So all right, let's just go to the regular example. So what I'm going to do is instead I'm going to link it. So this doesn't work for whatever reason, I'm not sure. Always interesting when things go wrong. Is that it? Did I forget to save it? No. I mean, I do that at least a dozen times a semester, but thank you very much. All right. So, and now when I run it, oh, come on. Not find main. Oh, yeah, sorry. Okay, perfect. All right. So I forgot to save the foo file. Whew. All right. Yeah, it's always good though. I like it. It's not the, trust me, it's not the last time it's going to happen. And it's a good opportunity for everybody to help try and problem solve and find the bugs. C++ is a complex language, and sometimes I forget or make silly mistakes the same as anybody else would. So it's a good opportunity for us to try and troubleshoot this together. And I often forget to save the file, especially when it's being blocked by this thing. But all right, so what happened is this worked. But what happened precisely is, here, I don't need these anymore. Right, so it still works, even though I didn't have the namespace standard and all of that stuff, because when I include just a file, all it does is basically, the compiler is really primitive, right? So it starts reading here, it says include input output stream, great, using namespace standard, awesome. Include foo.cc, now it will jump over here and just keep reading. And it says, okay, so you've declared this function foo, you've given me the code. I'm still in the standard namespace. I still have this input output stream library. And then when it's done reading that, it jumps back here and picks up right here. So this is essentially as if I copied and pasted this entire file into here. So although it works, and it's a little bit neater than actually putting my foo function above my main function, I still run into the same problem that when I compile, I'm recompiling everything at the same time. And if it's a big program, that's going to be a big problem. All right, so good questions so far. All right, so now we'll show you the right way to do it. So I want to compile them separately, but I don't want to do this. Again, this is just defeating the purpose of compiling them separately. So since I'm going to compile these files separately at this point, I do have to let the compiler know that, yes, there is a foo function. Here's what it looks like. I'm not going to give you the code yet, but I promise somewhere down the line, you're going to see the code for this. And then when I go to foo.cc, well, now I should start getting errors. I do actually have to, since this is a standalone file that I want to compile in a standalone manner, I do have to include any libraries I'm using. And if I want to scope in the standard namespace, I have to do that as well. So what I'm going to do is I'm going to compile. So -c means compile to an object file. And I'm going to compile foo.cc. And then you can see here this foo.o appeared, right? So this is what's called an object file. It's machine language, it's machine code, but it's not an executable. I can't run it. Right? Permission denied. There's really, I mean, it's in some sense runnable, but there's no flag, there's no main, but I could compile a main into an object file. This is machine code that I'm going to link in later. At this point, maybe I want to do the same thing with my main. So I'll say main.cc. So the -c means object file, right? So -o means output file, -c means object file. I find it a little bit confusing, but so now I have main.o and foo.o, and I want to link them together into an executable. So I'm going to say G++, my output file is main. And then I'm going to say, well, these are the files that I want linked into my main executable. All right, so yeah, so now when I run it, I've compiled them separately, right? And then in the linking stage, I tell the compiler here that there is a foo function. Here's how you use it, and I'm going to call it here. So when it compiles this into machine language, what's missing here is just a memory address. So I'm calling this function, but I don't know where it lives yet. When I link them together, then it supplies a memory address here. And so when I call this function, it jumps to that code. Okay, so that's all of the, when we compile and write our programs, we're basically going to compile them into a lot of object files, basically one per class, essentially, and then link them together, which makes it, I mean, it doesn't take long to compile these programs that we're making, but yeah, when you start to write bigger programs, this will make a big difference. So questions? All right. All right, so program building in general is translating source code, which we write into machine code, right? So we write computer instructions in some high-level language that resembles English. This language can't be understood by the CPU. It's just a text file. The compiler takes it and converts it into machine code, which are instructions that can be understood by the CPU. And then what we do is program building is we make an executable from one or more source files, often using the intermediate object files. Right, so at the end result, we have a binary file that can be understood by your computer and can be run. It's executable by default after we compile it. If you port it to some other machine, I believe the flag gets tripped so that you can't execute it until you give it permission. In general, these are not portable between platforms, right? I can take this, compile this binary file and run it on another Ubuntu machine with the same compiler and it'll work. But between different platforms, it will not. So typically, when we write executable, it contains code from many sources. Code that we write, other people's code, libraries that we import. But for each executable, there is one jumping off place, which is the main function. Okay, so we always have to include a main function. Yep. What's that? Sorry. The Intel? So yeah, this is, I'm pretty sure it'll work because technically there's another layer, there's microcode underneath this machine language. So the microcode talks directly, right? Like every program in computer science is solved with an abstraction layer. So there might be a different instruction set on that CPU, but the interface, how my compiled machine code talks to it is the same. So yeah, there is another layer underneath there. Technically, you're not quite running on the metal with this. But yeah, there's the microcode that is CPU specific. So yeah, it should work. I mean, I would hesitate to make a blanket statement for every single architecture, but in general, it should work. Okay, other questions? All right. Okay, so yeah, we compile our C++ code, we turn it into object code, and generally speaking, each source file should be compiled into an object file, and then we link them together after. Yeah, so as mentioned, right, I compiled my main function. I said there's a foo function. Here's how you call it. I don't know where the code is yet, but when I link it, the compiler is going to plug the proper memory address in there for that code. Right, so now our program writing and compiling looks like this. I make a bunch of different source files. I compile them individually, all at the same time, but individually. And then maybe I also grab some libraries like the IOStream library, and I link it all together into an executable, and that's my final program that runs. Okay, so just to review, I can compile into a single output file using the -O, right? I can just take any source code, a single file, and compile it directly into source code. I can take that single file and make it into an object file, and then in some sense just link it. All it's going to do is flip a bit to make it executable. I can compile multiple files into object files and then link all of those together, right? So that's what we did in the final step. Okay, so all of this is going to get complicated rather quickly. So to help manage this complexity, we're going to use what are called makefiles, right? So makefiles are going to automate this for us. They're pretty smart. Again, they leave a lot of the cleverness up to you, right? So we're going to use very, very simple makefiles in industry that they get really complicated really quickly with all kinds of dependencies, and Sean has more experience with that than I do, but even at this low level, you start to see, we'll see probably later on when you do things like, well, if object A contains a reference to object B and object B contains a reference to object A, all of a sudden I have a big mess in my makefile. 30 years experience with makefiles. So yes, direct all your questions to Sean. He's happy to answer them. So yeah, what the makefile does, it does a few things for us. I put a bunch of compile commands along with, maybe some of them are to object code. And then at the end, these are all gathered together and made into an executable. What the makefile does is says it keeps track of what needs to be compiled. But because we list the dependencies, right? So we say we list, well, I'll show you. But sometimes dependencies can get difficult. Again, we don't spend a lot of time on makefiles, and I try and keep them simple. I put hardly any thought into them at all. So it's possible at some point something's not compiling that should be. If you're using your virtual machine, there's also the issue of your clocks are not synchronized, right? So then it can think that maybe a file has been, a file is current when it's not. So sometimes if you get stuck and you can't figure out what the problem is, you can do a clean step. So a clean basically deletes all of your object code and binaries and starts fresh. That can sometimes solve your problems, especially with these virtual machines. Again, I want Sean to, if you find the mistakes in my makefiles that are causing this problem, let me know. I'm assuming it's the virtual machine, but it could just as easily be me. But yeah, try a clean step if things aren't working. Okay, so makefiles are are going to help us to keep these all these compilation steps automated for us. So a makefile typically will look like this. So here I have a command called foo, and followed by a colon. And then after that command, I'm going to list the dependencies, right? So these can be files or these can be other commands. The makefile will figure out which you mean. In this case, I say, well, this foo depends on foo.o. And so if foo.o has changed since the last time I compiled foo, then I should recompile foo. If foo.o and foo2.o have not changed, then I don't need to recompile this step. But if either of these are changed, then it's going to run this command. But it actually does something even a little more clever than that. It says, well, foo.o is a dependency. And look here, I have a foo.o command. So now the makefile is going to check this dependency. So it's going to look at foo.cc and say, well, has this file changed since the last time this was compiled? And if so, it's going to run this command for me and then come back up here and run this command, right? So it keeps tracks of these dependencies so that we don't have to. Right, so we have our command, we have our dependencies, and then this is the command that is run from the command line, right? Basically like we just did. So this is going to make an output file. Yeah, that's a, sorry, no, that's right. So that's going to make an output file called foo, an executable that links foo.o and foo2.o together. In addition to that, we usually have an all command and a clean command. So if I have a makefile and I just run the command make, as you'll see, it will look for the first command. In this case, that's the all command. Maybe there's multiple executables. So I would list them all here. Yeah, so, and clean, if I want to, again, if things aren't compiling and they should be, maybe I want to start fresh. So I have a command here, this rm-f for force. So I think it might be the executables that it might ask you, do you really want to remove this? Well, the -f just make sure that it goes ahead and does that. All right, so I want to remove the executables. And here, there's a little wildcard. I want to remove all the object files. And then when I run make next time, it'll compile everything from scratch. And then your problems will magically go away. Yeah. All right. So let's look at an example with a makefile now. All right, let's just write a makefile. I'm going to write, again, this capital M is important in a Linux environment, right? It's case sensitive. So we call it makefile. You can make files, you can make makefiles with other names too, but then you have to specify that, you know, it's a special command to compile these. So I want to set up my makefile so that it automatically compiles this main and this foo. So, well, let's say foo.o will be one command. It depends on foo.cc. And then if foo.cc is changed, I want to recompile foo.o. I want to do the same thing for main.o. This depends on main.cc. And then finally, main depends on main.o, foo.o, and if either of those are changed, I want to compile this into a main executable, and I want to link main.o and foo.o together. Okay. So yeah, we have a basic makefile here, right? So if I run the command make from the command line, well, let's actually just remove this and this. Okay, so I don't have any executables anymore. I don't have any. Yeah, I'm getting to the clean. It's coming. So so now I'm going to run the make command. And what make does is it looks for a make file that's called make file. And then it runs the first command, which you can see is main. So yeah, and then it said, well, main depends on main.o and foo.o. And it sees that, well, nothing has been compiled up to this point. So it, compiles main.o here, compiles foo.o here, and then links them in the final step. It handled all the dependencies for me. And now I can just run my main, right? If I run make again, it says main is up to date. I haven't made any changes. Maybe I want to say, well, hello again from foo. Here is a change. Oops. I save that. I run make. And you can see now it said, well, foo.cc got changed. So it reran this command. It recompiled foo.o, but it didn't recompile main.o, right? So main.cc didn't get changed. So the make file recognizes that. But then it also recognizes, well, if foo.o changed, then I have to relink these two into my executable. So yeah, it handles all those things automatically. And then I have my main. Okay, so that's how we handle all that complexity. And again, it is convention most of the time to include an all step. In this case, I only have one executable, so my all will simply be main. There's no command associated here. I just want to say, well, let's make a clean step so I can clean this up. My clean step, I actually have no dependencies. I don't care what happened. If I run clean, I want everything removed. So I will remove main and then star.o to remove all of my binaries and object files. Okay, so I run make clean. It removes everything, and then I run make all. And it says, all just says, well, I want to run the main command, and then main figures out all the dependencies. Common student error for clean is what? Aha. Yes, don't do that. So yeah, remove star. That would be very bad. That would remove. Yeah, you can do a lot of damage with the remove command. So be very careful with it. Yeah, star.o. Okay, so our make files will look something like this in the beginning. We'll get into, they can have their own variables and things like that. So we'll get into slightly more complicated versions. Again, I don't do anything fancy with our make files. If you spot a dependency error, please let me know. But yeah, any questions? Okay. All right. Okay, so that takes us to the end of the introduction, or 8 o'clock. So we've got about 25 minutes left. So we'll move on to basic language features. A lot of this is going to be review. I kind of apologize, but we are building everything from the ground up. I want to make sure you have all of the proper tools. So yeah, we're going to talk about a little bit of the basics of C++, how languages are, in some sense, how languages are built. Yeah, so this seemed like a good idea at the time, but basically this means that, we handle everything ourselves. There's none of this, memory being handled for us. G++. No, I don't use any. I don't know. If you want to explain wall, you can, but yeah, I don't get too much into those sorts of things. I've used Valgrind perhaps a little bit. There's lots of options that you can use. when you're compiling and things like that. But okay, so a short history of programming languages. Goodness gracious. So programming is actually, computers and programming are actually pretty recent. Actually, the idea of computers has been around for a long time, but in 1951, they made assembly code. There used to be a class here at Carleton where you could take assembly. It was a good class, it's a fun class. It teaches you a lot about architecture because it's very low level stuff. You're dealing directly with registers and things like that. 1957, Fortran, Lisp, COBOL. If you know Fortran and COBOL, you can make a pretty good living still by working on banking software and things like that. BASIC in 1964, B in 1969, the predecessor to C. Pascal in 1970. So C was 1972. And then Prolog and Scheme. And we use all three of those still at Carleton, right? So Prolog, Scheme, you will be taught those. So a lot of these languages have lasted a long time. C++ in 1980, it was called C with classes, renamed in 1983. Now, of course, the languages have gone through a lot of evolution since then, so they're not precisely the same languages, but still the same thing. C++, a child of the 80s, that could be why it's so, it has no rules. Ada, I don't remember, was that for the space program, perhaps, that language? Space program or the military, I think. Objective-C, which I think is no longer in use, it's been replaced by Swift. But Python, 1990, Java, 1995, JavaScript, PHP, they're all pretty young as far as languages go. It's a really young field. So what's the most powerful language? They're all the same. They're all Turing complete, which means by power, if by power you mean the set of problems that are solvable by a computer. There's no difference in that sense. It's not like one can magically do something another can't, but they're specialized at certain things, right? So some are fast. C++ is fast, C is fast. Some are more convenient, like Python, compiled versus interpretive, all of those things. So yeah, we've talked about this. So all programming languages have in common that they manipulate data, right? This is sort of information technology, so to speak. So we're going to store, operate on data. So how do we store data? Well, we have primitives, int, float, double, character, Boolean. These are all roughly the same size. They're not exactly the same, but in terms of computers, an int is 32 bits or 4 bytes. A float is also 32 by default. Double is 64. Character is 8, I think. I think Boolean is 8 as well. But roughly speaking, none of them are super huge, right? So these are small. I can copy them. If I have a 64-bit machine, that's one trip on the address bus, right? 64 bits on my address bus, I can reset any primitive data type in one CPU call. Then we have aggregate data types. So basically, I take a bunch of these primitives and I cram them together, right? You've done that in C. So you've seen structs. In C++, you can use structs or classes. And in fact, they are almost exactly the same thing, except for classes, except for the access modifiers that are by default, right? So I can have a class I can have a subclass of a struct, and I can have a substruct of a class. They're basically interchangeable. But yeah, we'll talk a little bit more about that a little later. And another data type we have are actually memory addresses, right? So these are pointers, right? So I store in my variable stu. There's some memory location, and in that memory location is another memory location, right? The address of it. So all memory looks the same, right? It's just a bunch of bits crammed together. But how the compiler knows how to interpret it, well, we tell it, right? So C++ is a strongly typed language, which means that, well, we say we give each variable, we declare a type, and that tells the compiler when it looks at this, oh, do I interpret this as a float? Well, that's going to be different than if it interprets it as an int or a double or a character or what have you. All right, so each, when I'm looking at memory, I'm usually looking with a label. All right. So each variable has a name. It has a type, which is the label that tells us how to interpret it. It has its own address as well, right? So it resides somewhere. And it has a value. The value is stored in the address. All right, so we're going to talk a little bit about the memory model of C++. We're going to come back to it again and again. I'm going to, in some sense, throw a lot at you initially, but we're going to revisit it and revisit it and revisit it until you know. But in C++, there are two main places for memory. In fact, in most languages, we have two main places, but in C++, there you have more of a hand in where memory goes. So there's the function call stack, right? So this is, there's a data structure called a stack. And when we make a function call, it stores a bunch of information about that function, along with, you know, variables that we declare locally in that function. It's fast, it's convenient, it's temporary, right? Once we return from that function, all that data gets deleted. And then there's the heap. It's slower to allocate, right? It's complicated because the function call stack is very simple. We'll talk about it in a second. But the heap, I can choose when I delete something from, which means that I can get holes in my memory. So keeping track of where things are stored on the heap is a lot more complex. So that makes it slower to allocate, but I get to control the lifespan of any data that I store on the heap. Also, the heap is more flexible. The stack will run out of room. It's easier to run out of room on the stack than it is the heap. The heap can always make calls to ask for more memory, but the stack basically will bump into the heap at some point, and then you have a stack overflow when you're done. So function call stack, right? So I start with my main function. When I call main, basically a bunch of information goes on my function call stack here, metadata, variables, things like that. Then I call my foo function, and what's called a stack frame. Another stack frame goes on my stack with information about this new function foo, including all the local variables and any metadata that we need. And then maybe I call foo2, and this puts another stack frame on my stack. Okay, so why is it called a stack? It's because it's very organized in how we add and remove information. So once I return from foo2, this is deleted, right? So this entire stack frame, I mean, we don't explicitly delete it, it's still there, but it's going to get overwritten the next time I call a function. So once I'm done with this function, I return to here, and then I continue executing there. But what that means is that I don't really, managing this memory is simple, it's fast, right? I just change a pointer, that's it. And then when I call a new function, I'm going to overwrite that, but that's fine. The heap, on the other hand, it's sort of a mess because I can, you know, if I just add stuff to it, then everything's added in order, but then maybe I remove something, and now there's a hole. And if I delete this int, and then I add another int, I have to, you know, the heap has to know that, oh, there's a hole here that can store an int. So it's more complicated. But yeah, so anytime I use the new keyword, I am putting memory on the heap, right? So again, we're going to come back to this again and again. I'm going to throw a lot at you initially, but you know, we're going to revisit these ideas. Initially, when you write assignment 1, if you're not experienced with C++, if you're experienced with C++, it'll probably be very easy. If you're not, sometimes it's going to be just pattern matching, right? every programmer starts by pattern matching, or, taking a piece of code that works and then modifying it to try and make it do what you want. Sometimes you don't always quite understand what you're doing, but you just know that this syntax works. That's okay. We're going to revisit these ideas until we understand them. But the main point here is that if I want to put memory on the heap, that happens anytime I use the new keyword. And if I use the new keyword here, I'm declaring a new int. So, and I declare a pointer that points to it. So new int returns a memory address that I'm storing in this pointer. And then every time I want to access this memory address or this value here, well, I have to what's called dereference the pointer. Okay, and then this gives me back the value, and then I can treat it like a regular statically allocated int. Okay, and this variable remains in memory until delete is called. And there's a, we're not going to enforce it on assignment 1. Memory management will be a bonus. So if you successfully avoid memory leaks, you will get bonus marks. If not, that's okay. We're going to come back to it on assignment 2. Assignment 2, you will be responsible for properly managing memory. But basically, this integer will live on the heap until I call delete, at which point the operating system removes it, and then we proceed. Okay, so there are 2 main ways to declare a variable, and they are sort of loosely associated with the stack and the heap. But if I say statically allocated, what I mean is I just declare a variable directly. And what that means is that memory is allocated where I've declared it. If I declare it in a function, it goes on the function call stack. But maybe I declare it in a class or a struct, then it's going to be allocated with that object. Okay, and if that object is on the heap, it'll be allocated on the heap. If it's on the stack, it'll be allocated on the stack. But when I statically allocate an object or a value, it's deleted for me. I don't have to manage the lifespan of that. On the other hand, when I dynamically allocate, I do have to manage the lifespan of that. This will exist until I call delete. If I don't call delete on it at any point, that's a memory leak. Okay, so we're going to revisit this idea in the memory management section. I do encourage you to try it on assignment 1 to make sure that you manage all your memory correctly. If you don't worry about it. They're just bonus marks. Right now, we will focus on creating these variables that we need to use and then using them correctly. And then later, we'll focus on managing them correctly. All right, questions? Okay. All right, 10 minutes. All right, so structs in C++, so structs and classes. Again, they're the same thing. The only is the access modifiers. As far as the compiler is concerned, they're precisely the same. But a struct, everything is, all members are by default public, whereas a class, all members are by default private. Now, you may think that's nothing but a philosophical difference, and you're right. But we're going to be focusing on classes. We're going to be focusing on keeping as many things private as we can, right? So that's the idea behind encapsulation. And what this does is that, well, if you don't need access to a piece of data, if I just use that internally in my object to, keep track of something, then I shouldn't give you access, because if I give you access, you might use it. And if you use it, you can destroy the internal state of my object or corrupt it or make it, unpredictable. So we're going to be, when we write code, we're going to be using what's called the principle of least privilege, is that we want to hide as many details as we can, because when we expose details, people think they should use them. And in some cases they shouldn't. So in this class, we're going to be using classes. Structs do have their place in C++, but we're not going to be using them. You've used them in C. We're going to focus on classes here. All right, so very simple stuff here. Operators, again, this is kind of review, but Yeah, so we have data and now we want to do things with that data, and how we do things with that data is through operators. So we have our arithmetic operators, and order of operation applies here. So yeah, we won't go into all these details, but you should know how to use these. There are, I am going to ask you to do some application logic where you have to do some tests, maybe some Boolean logic, or comparisons or things like that. There are bitwise operators, which I could not for the life of me. Well, I know there's bit shift, but some of these I haven't used in so long, I don't remember. Assignment operators, and this conditional operator, which is sort of like an if statement, but it returns a value. Okay. All right, so let's look at any questions before we. Yeah, this is all review, but in the interests of completeness. So what I'm going to do is I'm going to take this. See if I can successfully drop it here. Yes. Okay. All right. So we were talking about operators. So we've introduced here. Again, we have our input-output stream, and we're using our standard namespace just for convenience. We statically declare 3 int variables, x, y, and z, and then we give them values. So we assign x the value 4, we assign y the value that's in x, and then we assign z this mathematical expression. So at this point, x is equal to 4, y is equal to 4, z is equal to whatever this evaluates to, but we have to remember the order of operations, right? So we're going to start by doing the multiplication. So x is equal to 4, so it's going to start by evaluating this. This evaluates to 8. And then these it will do in order. This should evaluate to 9, but I've gotten this wrong before, so let's run it and try. Permission denied, right. So that's one of the things, because I imported it from I compiled it on my other machine, basically my Linux partition, and then I copied it up into OpenStack. But when it did that, it by default turned off all the executable bits, right? So now I no longer have the permission to execute this. So this is, sorry, this is a Windows makefile, or at least partially. Okay, so I'm just going to make clean and then, yeah, all right. Okay, so 4, 4, and 9, and that was from, yeah. So yeah, order of operations, this gives you a 9. Just keep that in mind. I can compare x to y. If x is equal to y, I output equal. Otherwise, I output not equal. Again, nothing super earth-shattering here, but these are, of course, equal. This one's pretty neat. So this conditional operator, I can, because it is an operator, it returns a value, which means that I can embed it in places that expect a value, right? So my if statement, I can't embed in this cout statement, but this, I compare x to y, and then I have this question mark. And if it evaluates to true, I return this value. And if it evaluates to false, I return this value. So I can do that whole thing in one line instead of multiple lines. Yeah, so they are equal. Yeah. I don't want to spend too much time on this stuff. But you can do minus equals, right? So this takes the value of X and subtracts it from Z. This takes the value from Z and multiplies it times Y and stores it back into Y. So yeah. And this assigns assigns 7 to Y and X. Again, if you have any questions, ask them. I expect it's kind of review, but. And then we have our increment and decrement operators. Well, in this case, just the increment, and we have what's called prefix notation and postfix notation. And they behave similarly, but not quite the same. We're going to come back to this a little bit later, but you see these a lot, of course, in for loops. Basically, this will increment the value of X and return the incremented value. This will increment the value of X, but it returns the value of X before it was incremented. And that's really the only difference. The prefix operator happens to be a little bit more efficient, but yeah. All right, questions on that? All right. I will just quickly go over this again, and then I'll let you guys go. We're doing a lot of pattern matching because I do expect you to use pointers in assignment 1, and I expect you to use them at a point where they're not completely explained. Jeez. Sure. I don't know. I get so many of these callers trying to convince me that I owe them money or whatever. I don't know. So yeah, but this essentially does the same thing that we just did. In this case, I was statically allocating X, Y, and Z, but here I'm going to allocate them on the heap. So I declare 3 pointers, and then I assign them these integers from the heap, right? So now that we have these pointers pointing at actual memory locations, I can do all of the things that I just did. The difference being, if I want to access the value of X, I have to what's called dereference it, right? So you guys have done this in 2401, but it's of course easy to make mistakes with this sort of thing. But all of these operations are the same as the ones we just saw, except I'm dereferencing the pointers before I apply the operations. And then you can have funny looking things like this. Some of them become ambiguous, but not in this case. So what is that? Okay, so yeah, that's all of the same things, just using pointers. Again, I expect you to do that on assignment 1. All right, so that's it for today. I'll see you guys next week. Please come to I encourage you to come to the tutorial on Wednesday. And yeah, I will release assignment 1 sometime this week and confirm my office hours as well.